Hello, welcome back to Algebra. In this lesson, the title of this lesson is called Solving Compound Inequalities. This is part one of several. So in the last section, we learned how to solve inequalities generally. And it was pretty easy, to be honest with you, once you get the hang of it, because it's exactly the way that we solve equations. We had the one little rule about flipping around the arrow, but other than that, it was the same. And then graphing the inequalities became pretty easy once we showed you exactly how. Now in this lesson, you start to get to the point where some students start to get a little lost. There's no good reason for it though, it's not difficult. But when we solve compound inequalities, we start taking the idea of inequalities and bolting on more stuff to it. All right, so the bottom line is there's two kinds of compound inequalities. There are inequalities that involve and, the word and. They're called conjunctions because and is a conjunction in English. The word, the word and is what we call a conjunction. And then we have disjunctions, which are used with the word or. So the thing I want you to really remember is there's compound inequalities that involve anding two things together. And then there are compound inequalities that involve oring two things together. So what we're going to do is explain what those are, the conjunctions with and the disjunctions with or. And I'll graph a couple just to show you. They're very simple to understand. And then we'll solve a couple of problems and we'll increase the complexity as we go to give you the hang of it. So as I said, there's something called a conjunction. And what you need to know about that is that this involves the word and, right? Now, I'm going to talk about the next part in a second, but there's also something called a disjunction, and that is involved with the word or. I'm not going to write it on the board just yet because I want to do one thing at a time, but just know there's and compound inequalities and there's or compound inequalities. When you have a conjunction set of inequalities, compound inequalities that involve the word and, what does it mean? It means that the two inequalities must, let's write an M properly, must both be true. Right? I mean, when you think about what does the word and mean? Like, I like apples and candy. It means I like both of them at the same time. I like strawberry and I like banana. It means I like both of them, right? It's not an either or thing. When you say the word and, you're taking those two things and you're sticking them together and you're saying they have to both be true. If I like peanut butter and jelly, I like both of them, right? But if I say I like peanut butter or jelly, that's different. It means I can like this one or this one, but not necessarily both. So and or are different. So when we have two inequalities that we call a conjunction, we're saying that both of them must be true because they involve the word and. So let me cut to the chase and kind of give you an example. Let's say we have the conjunction or the compound inequality that looks like this. X is greater than 1, and you'll actually have the word and written down here in your textbook or your problems or whatever. X is less than 5. So the way that you know this is a conjunction is because it has the word and here. Later on we'll talk about or inequalities and it'll have the word or there. Okay? But what this means is because it has the word and, it means this must be true and at the same time this must be true. So if we go up to our graph and say, well, we know how to graph this and we know how to graph this, and we're saying that they both have to be true, we need to represent both of them on the same number line, both of them being true. So we go up here to the number 1 and we put a circle around it, right? And I would go ahead and graph everything to the right of the number 1 because that's what it tells me to do. But then I also have this other one. It's telling me X is less than 5. So I could put a circle around that one. So you see this one is telling me everything bigger than 1, which means bigger than 1 this direction. And this one is telling me everything less than 5 this direction. So if just this one were true, then it would be everything bigger than 1 off to infinity. And if just this one were true, it would be everything less than 5 to negative infinity. But since we're saying both of them have to be true, the only way that you can have something bigger than 1 and at the same time less than 5 is if just the numbers between them were part of the solution. So you see what I'm saying? You have a conjunction, is the fancy word we give you, for two inequalities that are joined together with the word and. That means that they are both true at the same time. So the way you graph it is you put this one on as a dot or an open circle. You put this one on as a dot or an open circle. And you say, okay, everything bigger than 1, that means I would go this way. And everything less than 5, that means I would go this way. But since they're both true, it has to be in between them because that's the only way both of these can be true at the same time. You see, the number 6 satisfies this inequality, but it doesn't satisfy this one. That's why the number 6 and all the other ones are not in, and all of these are not in, because it has to satisfy both of them. So all of these inequalities that are joined with the word and, they're going to look like segments on a number line. They're going to have an initial point, a terminal point, either open or closed circle, depending on if I have equal signs under here. But there'll be 2 points on the number line, and the and inequalities, the conjunctions, will be a segment of the number line. They'll be segments from start to finish. The ors will look a little different. That's why I'm emphasizing this. But that's what you have. Now, here's the part where people start to go off the rails a lot here. This and this is going to look like a line segment on the number line. There's another way to write this. Can write as the following. The and inequalities can be written like this. Instead of having 2 inequalities joined with the word and, you can also write it like this. Put your x and you write it as a double inequality. So what you do is you say x is greater than 1. Notice how the greater than sign is here. So it's greater than 1, but it's also less than 5. So here's what you do. You put a left-hand arrow, and then you put the number 1, and then you put another left-hand arrow, and you put the number 5. Now, when students see this, it totally freaks them out most of the time. Most of the time, people can understand this, but when you see this, they have no idea what's going on. What you need to do is, when you see a double inequality with a double arrowhead, you just focus your eyes on the x and you read it from the inside out. All it's saying is x is greater than 1, which is exactly what this is, greater than 1, because you read it from the inside out. Don't read it as 1 less than x less than 5. That makes no sense. Go stick your eyes in the middle and read it out. X greater than 1, that's this. X less than 5, that's this. So when you see a double inequality, never, ever, ever read it from left to right. Focus your eyes in the center and read it to the left and then read it to the right. And that basically recovers everything here. And when you see a double arrowhead like this, it means they're anded. This is greater than 1 and this is less than 5. That's what this means. So in your problems, half the time you'll see it written with an and the other half the time you'll see it written as a double inequality like this, or compound inequality, or a conjunction inequality, where you have the double arrowheads like that. But when you see these double arrowheads, you know that they're anded together. They're anded together. So x greater than 1, x less than 5, x greater than 1, x less than 5. That's what we've represented in our drawing there. All right, let's do another one just to kind of get to where we understand that. Let's say we have the inequality x greater than -4 and x less than 2, or let's make it x less than or equal to 2. Same sort of thing. This is true and this is true. So first, before we do anything else, let's graph it. -4, let's find it with an open circle. We'll put an open circle here. And +2, we'll put a closed circle because it includes the number 2, so we'll put a closed circle here. Okay, so we have open circle, closed circle. We're saying greater than -4 and less than 2. Greater than -4, oh, we got to stop here because it also has to be less than 2. So that means we will shade in between here. Notice that this is an and inequality, and once again, it forms a line segment on the number line. It's always going to be like that. And inequalities or conjunctions always form line segments, either open circle or closed circle, but they always will. Now, another way that you would write this is as follows. The way you write it is you stick, the variable is x, so you just start by putting an x there. And then you put your left-hand arrow, and you put another left-hand arrow on either side of the x. And then you read it, and you say, what does this mean? X greater than -4. X greater than -4. X less than or equal to 2. X less than or equal to 2. And this is how you would write it in terms of the compound inequality. So this is, or in terms of the double inequality, so and. So anytime you see this thing where you have double arrows pointing to the left like this, it means and. You can always read this and know that it's going to form a line segment on your number line. And then to graph it, like if you were not given this initially on the problem, if you were just given this, then you would read it from the inside out. You would say x less than -4, and you'd write that down, and you'd say x less than or equal, x greater than -4, you'd write that down, x less than or equal to 2, you'd write that down, and then you would graph it. So that's what you do. You decipher it by reading from the inside out, right? From the inside out. So that is what we call an and, or a conjunction inequality. Now there's also something called a disjunction. And I've already mentioned it a few times. It involves the word or. And what it means is either, not both, either can, or I should say, either inequality is true. I'll just put it like this. So you can think of that as, I like cars or motorcycles. I mean, it doesn't, when I use the word or, it doesn't mean I have to like them both. It means that I can like one or the other, all right? That's what it means. So if I were to give you an example of an or inequality, the way you would see it written down would be something like this, x less than 2, and you would actually have the word or in your problem, x greater than 6. This or this. It means I can plot this or I can plot this, but they both don't have to be true. So let's plot it. Let's take a look at x less than 2. So we find the number 2, we put an open circle there. And anything less than 2 goes on and on and on like this. And we have the number 6, which is over here. Unfortunately, it's toward the end of my number line, but it's everything to the right of that, like this. So you see what happens is for the ors, you don't have a line segment anymore. So for the ands, you have a starting point and an ending point and some numbers in between, and. That's what ands look like. Ors don't look like that at all. They're the exact opposite. It's either this side or it's this side because you can't have both of them true at the same time. You see, you can have a line segment true because you could be bigger than this number and less than this number at the same time. But you cannot have both of these true at the same time because you cannot be on this side of the number line and on this side of the number line at the same time. So these are ors. So the bottom line is I need you to kind of try to keep these in the back of your mind as we solve some problems. Right? The and inequalities are going to look like line segments. You can always write them like this with a left-pointed arrow and another left-pointed arrow like this, and you fill in the numbers according to what you have, and they are going to correspondingly form line segments. The ors are called disjunctions, where either one is true. You do not write these as a double-headed inequality. You can't, because the and is not true. It's either or, and it's going to form not a line segment, but two different directions pointed away from one another from two different points there. So let me go and erase this stuff, and we'll solve some problems to give you some practice. Okay, for our first problem, let's say we have x less than or equal to 3 less than 5. All right? So the first thing you need to know is that when you see a double inequality written like this, you read it from the inside out, of course, but you know right away before doing anything that it's an and inequality, and because of that, you know it's going to form a line segment somewhere on this number line. So what you do next is you read from the inside out and you decipher it. X greater than or equal to 3. You read it like this. So you write it as x greater than or equal to 3, and you write the word and to remind yourself that, and then you go the other way, x less than 5. So you have to go inside out to translate like this, and you have the word and, then you graph it. So you go up here to the number 3, you fill in with the number 3, and you say x is greater than that. Okay, but then x is also less than 5. So I went too far, and it's an open circle because it's not equal to 5. And there you go, that's what it is. And notice it does form a line segment because it is possible to be greater than 3 and equal to 3 and less than 5 at the same time. So that's half the trick, knowing that this is an and knowing how to break it out into the two pieces. Now what if our next problem said that t was less than 1 or t is greater than 3 or equal to 3? So because the word or is here, there's no double inequality. You can't write it that way. And because there's an or, you know it's not going to look like a line segment. You know it's going to look like kind of two different directions going off in the number line here. So let's see what it looks like. Less than 1. So we have an open circle for 1, and it'll be everything to the left of that. And then it'll be greater than or equal to 3. So we'll have a closed circle at the number 3, greater than or equal to that. And see how they look different. For the or inequalities, it's a left-handed arrow and a right-hand, or I say a left portion of the line, the right portion of the line, open and closed, and that's basically it. The line segments form the ands. All right. Let's do another one. Let's say we have y greater than or equal to -1 and y greater than or equal to 3. All right. So the first thing you want to do is kind of like, some of these are weirder than others, I guess I should say. So if you already have it split up into this and this, then you should just go straight to the number line and try to plot it. So let's find -1. Let's put a closed circle right there, and it's greater than or equal to that. Okay, that means it's going to be everything to the right like this. Then we go here and we say greater than or equal to 3. So this one looks a little bit weird. Here's 3, right? And it's everything to the to the right of 3. So what you're saying is this has to be true and this has to be true. So actually, this one is a little bit weirder. The only way that this can actually be graphed, if you have to be greater than -1 and greater than 3, is actually the only thing that works for this guy is to be greater than 3. Because this is an and inequality. The only way you can be bigger than -1 and at the same time bigger than 3 is just the numbers that are bigger than 3. You can't actually, even though I initially wrote them there, you can't be in this region because these aren't bigger than 3 as well. So you have to, this is kind of a weird one, I guess I should say, because normally the ands form a line segment, but because of the numbers that were chosen, it's actually just a one-sided bigger than 3. This is the only solution set that works because everything, of course, bigger than 3 is also bigger than -1, so it actually does work, but it's just a little bit weird, a little bit different. Okay, so the actual solution to this guy is y is greater than or equal to 3 is the actual solution of this inequality. Now let's take another one. Let's say we have t greater than 0 or t is less than 2. So because it's an or, we know we can't write it as a double-headed inequality, and we know that it's going to form generally a left-hand and a right-hand shaded region. So we go to 0, we put a circle here, and then we start shading to the right because it's bigger than 0. Or then we have t less than 2, so we put an open circle at 2, which means it's going to be to the left, which means it's going to include all of these numbers here. Now this one looks weird also. So because of the numbers that were chosen, even though it's either or, right, what actually happens is it could be this one or it could be this one. And so since we started at 0, everything to the right of that, or 2 and everything to the number less than that, that means that what actually is the solution of this, t is all real numbers. All real numbers. So that means the way I graphed it was actually, you don't realize this till you get started, but the circles don't really matter because actually all real numbers, the whole number line satisfies this or inequality. And if you want to check yourself, just pick a number. We're saying any number satisfies this. Okay, so let's pick 5. Is 5 greater than 0? Yes. Or is it less than 2? Well, it's not less than 2, but it's either or has to be true, so 5 works. Let's pick 100. 100's bigger than this, but it's not less than this. That's okay. It only needs to be one or the other. Let's pick 0. 0 is not greater than 0, so this fails, but 0 is less than 2, so this one is satisfied. Because it's or, then it satisfies one or the other. What about -900? -900 fails this one, but it passes this one. So as long as it passes one or the other, then it's in the solution set. So because any number you can pick is either going to be greater than 0 or will be less than 2, either one, then we say all real numbers actually satisfy this disjunction or this or-based inequality. All right? So it's a little bit weird. You have to think about it sometimes. The final one we're going to have looks like this. All right? So less than or equal to x minus 2 less than 3. So what you have to do is realize that it's written as a double inequality. It's written in this format. Even though it looks a little weird with the thing in the middle, it has a double arrow on either side of the variable. So because of that, you know that it's going to be an and type of situation. So the way you write it down, the way you proceed is you write it as an and. You say, what we have here is x minus 2 is greater than, reading from the inside out, or equal to 0. And you write and. So you have to kind of go backwards and say, middle part, x minus 2 less than 3. So you have to do this in order to get the right answer. You notice it's an and. That means you can read 2 inequalities out of it. This direction, here you go, and this direction, here you go, and they're joined with an and because of the way it's written. Then to solve it, you move 2 to the other side. Just add 2 and add 2. And you add 2 to this side. So you have x less than 5. Add 2 here, add 2 here. So you have x is, let me just double check, x is less than 5, x is Greater than or equal to 2, right. And then what you can do is when you get down to the end, you can rejoin them together because they're an and you can put an x in the middle, and you can put a double arrow here and a double arrow here. So we're saying greater than or equal to 2, less than 5. So this is the answer for the actual inequality once we solved it. So we say greater than or equal to 2. So here, greater than or equal means a closed dot here, and less than 5, open. And that means it's got to be a segment between these points. So when it was written like this, we knew right away that it was an and. So we knew it was going to form some kind of segment on the number line. So what we did is we broke it into two inequalities joined by an and just by reading inside to outside. We solved each one separately, and we get two answers, and we graph it, greater than or equal to 2 and less than 5. So greater than or equal to 2 is all of this, less than 5 is all of this, but the join of the and of them means both of them have to be true, which means the overlap, which means it forms a segment. And then the final answer is basically you can just circle this, or you can just rewrite it as a compound and inequality. So x is greater than or equal to 2, reading inside out. X is less than 5, just like it's written there. This is the solution of the problem. You write the solution in math form like this, and you write it as a graph like this. So compound inequalities in the beginning give students problems because it's a little weird that you would write an inequality with the variable in the middle like that. And I want to give you some practice doing it. We've done that here. We have a couple of other sections to get a lot more practice with more types of examples and more complexity. But the same thing is going to happen. We're going to break these things apart like we've done here, solve them, and then graph them. And what we're saying is that all of the numbers in this segmented region satisfy this inequality. Let's pick 3 for an example. 3 we're saying is part of the solution set. 3 minus 2 is 1. 1 is greater than or equal to 0, and 1 is less than 3. So all of the numbers that we say are in our solution satisfy our original problem. It's just that we have 2 inequalities instead of just 1 to satisfy. So follow me on to the next lesson, and we'll get some more practice with more complicated compound inequalities.